Hi, I'm John Miglosh, and today we're going to talk about statistics versus models. And before we start, I should admit I've never actually taken a statistics course, but that should make it easy to understand. But years ago, I was told by one of my clients, you violate every principle of statistical analysis. And I felt kind of bad about that. I thought maybe I should check this out. So one of my friends who had a PhD in statistics introduced me to Dr. Edward Lemur of UCLA, and we had the chance to talk, and I explained what I did and sort of how we did it. And he said, John, the way we teach statistics in the university, we suck every ounce of creativity out of our students. And he said, you don't violate the principles of statistics, you just have a higher standard. You require that not only is it statistically valid, but it has to also make sense. Okay, so what is the science of statistics? Well, it was created in the food process industry, and on the video they showed a truck tipping the whole truck. They put it on a ramp and they tipped the whole semi full of potatoes into this hopper. And they take a few potatoes and they test them very carefully. They punch a hole down the middle, and then when the potato chips get processed, certain potato chips have a hole in the middle, and they pick them out of the process, and then they test them further. And this way they know the quality of that truckload of potatoes, so that if there's a problem, they can reject the whole truckload. The principle then is, how many potatoes should we test to make sure that truckload is all right? Apparently they test the individual potatoes before they dump the truckload in. Anyway, so the more you test, the fewer you have to make potato chips that you can sell, unless you want a hole in the middle. And so what statistics is primarily about is, what size sample do we need to be sure that we have a good sample, that we have a good test? And you've probably heard in the polling industry, which we're getting calls night and day these days, that the test has a 95% certainty plus or minus 3% or something like that, and margin of error. Okay, well, that's coming from this idea of sample size. So when we got started modeling, I worked with Dr. Connie Bauer from Marquette University, and she said, I can do a valid model with 50 customers as long as they're the right 50 customers, which struck me a little humorous. And I said, Connie, we don't need to worry about which 50. We have big computers, and we can use all 15 million customers. We can use hundreds of thousands or millions of orders. There's really no need to restrict it, other than the size of the mailing or something like that. And so it's quite a different world that's happened because of the increased capacity of computing power. One of our analysts was from NASA, and he said, we used to do these same things, it just took us 8 weeks. So anyway, so we don't have to destroy any potatoes to build models. Okay, does that make sense? Now, another thing that statistics is really interested in is techniques. And I saw a website the other day that said, if that we're really expert modelers because we use a variety of techniques. Well, we don't use a variety of techniques. We principally use CHADE. And the reason we use CHADE is because it's a kind of a balance between hands-on. A technique like regression requires the modeler to have a pretty good sense of whether there's collinearity. That means two things looking like they're the same, like oftentimes income and education kind of go parallel in geodemographic data. And so you say, well, just use one or the other, but don't use both of them. Okay? And so the modeler has some power in regression to make some of those decisions. In fact, it's a requirement. Whereas in neural net, you kind of throw things at the wall and see what sticks, and you really don't know what's going on, but it's highly automatic, so it's nice. Well, ours, this A means automatic right there, automatic interaction detector. And it's it's automated, but it also lets us see what's going on. And so when we did the first fishing model for Cabela's, for their fishing catalog, I sent it out to Dick Cabela and I said, you know, he should look this over. And his people said, well, you know, Dick has, on a scale of 1 to 10, about a -3 of statistical expertise, experience, or even interest. And I said, well, he's paying a lot for it. Let's see what happens. So we explained to him, you know, that each box represented a number of customers, and there's a number in there, and each of these horizontal bars represented a characteristic. So normally it would be recency, although in Cabela's case it wasn't at all, and we can maybe go into that again. And as I said, if you have questions, send them in. We'll talk about them. But one of the advantages this had is that your very best customers may have a different next most important variable. Regression kind of says the most important, then the next most important, then the next most important. We don't have to do that. And so Dick would go through the tree and he would say, look at the characteristic, and he'd say, yep, that's what fishermen are like. And so, again, a big difference between the traditional science of statistics and what we do here is that we have to have it make sense. And so we use this technique mostly because we can see if it makes any sense, and so can our clients. So if you're not making money with data and you have big data, maybe the place to start is to see if you're using more of the science of statistics, or you're doing things that make it understandable, and even make it understandable for senior management. So if somebody's hiding things from you and you don't understand it, then it's much more difficult to predict what people will do, who will buy what markets are emerging. So have fun with your data. I'm John Miglash.